So you boys and girls get to start your first basics quiz. You'll take these almost weekly throughout the course of the year. Maybe not weekly, maybe bi-weekly, but it'll be a pretty common theme in this class. So let's start off with the first one. It's a two-step equation. And we're just trying to reinforce basic algebra, get some of you guys up to speed, little things, always things that we can get better at. We're going to add 3 to 8, and by the way, there is no calculator allowed on this thing. You are expected to know what 8 plus 3 is. It's 11, by the way, if you didn't know. Now, the understood multiplier between 3, the understood symbolism between the 3 and the x is a multiplier, and the opposite of multiplication is division. And there's my answer, 11 thirds. That's it. All right. Number 2, the property that jumps out to me that I can do is the distributive property. I could also divide both sides by 2 if I wanted to. There's 2 ways of doing number 2. So anyways, 2 times 5 is 10, 10x, 2 times negative 4 is negative 8, and we have a 12 on the right-hand side. Now, we do things in the easiest order possible, and it's easier to add than it is to divide, so we're going to do the addition first. So my next line would say 10x is 12 plus 8, which is 20. And now I'm going to counteract multiplication through division by dividing both sides by 10, and that gives me an x value of 2. And that's what we're doing on these 5 equations. We're solving for x and nothing more. All right, the third one. X is on one side, numbers on the other. If you're a shift x's left person, then shift them left. I shift them whichever way is easier. I'm going to shift my x's over here and my numbers over here, okay? Remember, if you jump equality, your signs change. So the left-hand side would now have a positive 21 minus 8 equal to the right-hand side, which is a 9x that I did not move, subtract 5x. And again, that was a positive 21. 21 minus 8 should be 13. 9 minus 5 should be 4, so 4x. And then again, the opposite of multiplication is the division operation, so x is going to be 13 quarters. All right, moving on to number 4. Again, do the easy things first. The easy thing to do on number 4 is to subtract 2. And you now have 4/5 of x equals 8 minus 2, which is 6. Now, I say 4/5, but I'm also reading 4 divided by 5, right? That's 4 divided by 5. The opposite of division is multiplication. So I'm going to multiply both sides by a 5, or the entire thing by a 5, however I like it. The 5's do cancel, so my next line is going to be 4x, because the 5's canceled, equals 6 times 5, which is 30. Now, the opposite of multiplication is division. And please don't be the kid who stops at something like this. Like, those are both even. I'm going to count off. If you don't simplify 30 over 4, I'm going to count off. Those are both even. That's 15 over 2. They're both divisible by 2. And yes, you are 16, 17, and 18 years old. I expect you to be able to do things like that. The state of Tennessee expects you to be able to do things like that. Everybody does. All right, number 5. There's a hard way of doing number 5, and there's an easy way of doing number 5. The easiest way to do number 5 is to use what we call the zero product property. And I'm going to switch on over to typing on this one. So the zero product property says if A times B is 0, then A or B is a 0. That's what the zero product property says. So I can use that property on this one. This says that 2x minus 1 is equal to 0, or it says x plus 4 is equal to 0. Now, 2x minus 1 is a two-step equation. We add 1 to both sides and we divide by 2. X is a half. X plus 4 is a single-step equation. We just subtract 4 from both sides and x is negative 4. That one has 2 answers. Easy peasy, lemon squeezy. 6, 7, and 8 are supposed to strengthen your knowledge of the distributive property and the double distributive property. Draw the arrows. You know, don't be the kid who doesn't get these properties. They are properties that are taught to you from an early age. We're going to distribute the 2x to both the 5x and the negative 8. Now, 2 times 5 is 10. And a big one that I've noticed over the years is that kids don't realize that x times x is x squared. I don't know how you made it this far without knowing that, but anyways, x times x is x squared. 2x times a negative 8, well 2 times a negative 8 is negative 16, and you still got the x floating around right there. So that's the distributive property. 7, most likely your Algebra 1 teacher used an acronym called FOIL. First, outer, inner, last. So here we're going to do x times x, that would be first, and that's x squared, that's first. Outer, negative 2 times x is minus 2x. Inner, 6 times x plus 6x. And then last, 6 times the negative 2 is minus 12. Little things I've noticed over the years is kids think you're adding. You're not adding, you're multiplying. That's the big deal. Alright, so we'll do a simplification step. Combine like terms. A negative 2x and a positive 6x add to 4x. And then we have the minus 12. That's called the double distributive property, or the FOIL technique, if you like the word FOIL. It's up to you. Alright, you got one with slightly bigger numbers. 4x times 3x is 12x to the second. 4x times 5 would be plus 20x. Negative 3 times 3x is minus 9x. And negative 3 times 5 is minus 15, or negative 15. And then we combine like terms again. 20 minus 9 is 11. And then we have the minus 15. So 12x squared plus 11x's minus a 15. That's number 8. And moving forward with our lives. Factoring. So we are factoring. This is the reverse of what you just did. Because see, what you just did is you found the product of two what we call binomials, and you created a trinomial. So we're going backwards here. We're thinking about how do I make this trinomial as the product of two things. And if you understand the FOIL method that you learned in Algebra 1, factoring is actually quite easy. I teach a technique mainly called guess and check. It takes an x and an x here to create the x squared that I had out here. Okay? So I focus on the beginning, and then I focus on the ending. Factors of 10 could be something like 2 and 5. And I'll try 2 and 5, and I'm going to show you one that doesn't work. If I do a 2 and a 5, I would have a 2x and a 5x. And you can see that my goal is to have 9. That's called guessing. And then I checked it, and I discovered it didn't work. So I erase. The other factors of 10, oh, it's being weird. Let's just erase it all. The other factors of 10 might have been 1 and 10. Okay. Let's think about what we've done here. The inside still creates x squared. The outside is creating a 10x, and this inside is creating an x. Can I get to a positive 9 with a 10 and a 1? I can, if I make the 1 negative and the 10 positive, because 10 minus 1 is positive 9. So that is therefore how it factors. Factors is x minus 1 times x plus 10. Now you might have some nightmares about factoring from when you were in Algebra 1. I can't fix that, but I can tell you that factoring is a big deal in my course. So I suggest you figure out how to factor. Alright, now you're going to factor this one. This one's actually what you call a perfect square. There's lots of ways of creating a 4x squared. You might do 2x and 2x, or you might do 4x and x, okay? Then there's a 35 there, which there should not be a 35 there. That should be a 25. That's a 25, not a 35. Factors of 25 are set in stone. They could be 5 and 5, or maybe 1 and 25. But anyways, 5 and 5 is a good guess. And 2x and 2x is a good guess. A lot of times when you're factoring where a is not 1, you pick the things that are close together. So let's check this out. 2x times 2x would be 4x squared. 2x times 5 is a 10x. 2x times 5 is a 10x. And 5 times 5 is a 25. Now my goal was to get to negative 20 in the middle. If I make those both negative, I'm there. And a negative times a negative is a positive. So it factors as 2x minus 5 times 2x minus 5. Alright, we have function notation. Given that f of x is 5x minus 6, find the following. Find f of 3 and f of negative 1. Now, this is as simple as noticing that the x has been replaced with a number. Like, look at the lineup process. Literally says that x was replaced with a 3. That's what it says. F of 3 says x is 3. Everywhere you see an x, plug in a 3. So this becomes 5 times 3 minus 6. 5 times 3 is 15. 15 minus 6 is 9. F of negative 1 says that x has been replaced with a negative 1. So 5 times a negative 1 minus a 6. And you'll see a lot of kids miss this. Because what are we doing? We're taking something away from a negative. And oh my sweet Jesus, the number of mistakes kids make with things like this. But anywho, I know that that's negative 11. You'll notice yours had a disclaimer at the bottom, hey you, there's a backside, because a lot of kids for some reason think a homework assignment should only be one side. It's not. There's a second side. Find the slope between two given points. So you are expected to know the formula for slope. It is taught to you in middle school, and it's done repetitively throughout high school math. That's the formula for slope, y2 minus y1 over x2 minus x1. We get our order pairs from the points that are given. First order pair is x1, y1. Second order pair is x2 and y2. And then we just plug things in. We just feed the formula. So y2 is negative 8. We're going to take away y1, which is 3. It's sitting pretty over x2, which is 9. Take away x1, which is a negative 2. And there will be a lot of kids who make mistakes right there. They'll probably just say minus 2. It's minus a negative 2. Now, taking away a negative is addition. So 9 plus 2 is 11. The numerator is negative 8 minus 3, which is, interestingly enough, also 11, but it's negative. And this simplifies down to negative 1. That is the slope between those 2 points. Fall 1, run 1. All right, the last actual question, the rest of them from here on out are bonuses. A line has a slope of a half and passes through the point 4, negative 3. Write an equation of this line in slope-intercept form. And what I have taught you all to do is to use what we call point-slope form. Point-slope form is y minus y1 equal to m parentheses x minus x1. And again, we get x1 and y1 from the given point. And then we feed this thing. We do not replace y with anything. We do replace y1 with what it is, and y1 is a negative 3. The slope is given. That's m, by the way. Don't be that kid. Slope is a half. We don't replace x with anything. We replace the x1 with 4. And then we do what we can do. Like, we know that taking away a negative is addition. We should know the distributive property. A half times x is a half x. A half times 4 would be 2. A positive times a negative is a negative. Stuff like that. We don't quite look like slope-intercept form, which, by the way, is y equals mx plus b, if you didn't know. So we just need to go ahead and move that 3 on over. And the opposite of addition has always been subtraction, and it always will be subtraction. So negative 2 minus 3 is negative 5. And that's what I'm asking for, slope-intercept form. That's an Algebra I standard. Everything on this thing is an Algebra I standard or lower. This is not an Algebra II quiz. This is Algebra I or lower, okay? You ain't doing Algebra II yet. All right, given f of x is x squared minus 5, find the average rate of change over the interval negative 2 to 2. Now, average rate of change is just a fancy way of saying slope. Now, we do tend to teach a slightly different formula for it because we're starting to get into what's called function notation, and slope is not in function notation. So I'm going to do some abbreviations here. The average rate of change is what we call f of b minus f of a over b minus a. And that should look like slope to you, because when you talk about f of b, you're talking about an output. Like, this is literally y2. That's y1. That's x2. That's x1. It's just a rewrite of the slope formula. Now, how do we get f of b and f of a? Well, the first number in the interval is a, and the second number in the interval is b. So I'm going to find f of b by plugging in a positive 2. Everywhere I see an x, I'm a 2. So it becomes 2 squared minus 5, which is negative 1. F of a is found by plugging in a negative 2. Notice how I wrap in parentheses? Anyways, if you take a negative 2 and square it, you have 4, and 4 minus 5 is still negative 1. This thing should have an average rate of change of 0, this particular one. It's because I did it with a quadratic, which has symmetry. So f of b was negative 1. I'm going to take away f of a, which is also negative 1, and the denominator is b minus a, which is 2 minus a negative 2. Now, taking away negative is addition. Negative 1 plus 1 is 0. 2 minus 2 is 4, and 0 divided by anything other than 0 is 0. Now, if you didn't know 0 divided by 4 was 0, ooh, it's going to be a bad year for you, kid. Figure some stuff out. And these are all bonuses, too. So you've got a funky looking graph. It's actually called a piecewise graph. And you're supposed to find everything about it, starting the domain. And do remember, domain is x values. Okay? Now what's happening is this thing is running left forever up to this open circle. And that is an open circle. It's a hole in the graph. There is no solid dot. It is not a solid dot. You cannot actually put your pencil on it. If you try to throw something in that hole, it disappears into the hole. But it runs left forever, and as you work your way left, you get ridiculously close to negative 2, but you can't actually be negative 2 because negative 2 is a hole in a graph. Alright, so that's part of it. That's only the domain for that piece. So we are this, and we use the letter U, it kind of means and. This is called union, unioned with. Boy, that looked bad, didn't it? Unioned with this piece, which starts on the other side of negative 2, and I can literally hold my pencil all the way until I hit an x value of 6. So union with negative 2 to 6. Now I'm going to put a bracket on that 6 because that's a nice solid dot. Okay? Range is going to be your y values. Alright, so this thing, as far as y is concerned, is rising from negative infinity all the way up to negative 2. And range is tough for a lot of kids to get. So if you just look at that piece stops at negative 2. But I also have to look over here. Is the function, or does the function actually have a y value of negative 2? It does. It goes all the way up here, and you might see a hole and be like, okay, y can't be 1. But this piece of the graph is suggesting that y can be 1. So its range is actually negative infinity all the way to a value of 1. I understand why kids have confusion on this. It's because you're looking at pieces. Okay? That's the deal. You're looking at pieces, and you don't try to think about the whole thing. Domain is a lot easier on a piecewise function than range is. Range is tough for kids. All right, B4 says f of negative 2, and that is asking what is y when x equals negative 2. So I'm going to find negative 2 on the x-axis, which is right here, and I'm just going to kind of look at these 2 points, and I see open holes. There is no y value. And what we do, because we're lazy, is we write DNE, which stands for does not exist. Because there is a hole in the graph. There is nothing there. Okay? Next up, what is f of 3? And again, this is what is y when x is 3. So here's where x is 3, and I look up and I see a y value of 1. So f of 3 is 1. B is the average rate of change over the interval from negative 3 to 6. Now, I told you earlier, and I meant it, that average rate of change is just a nice way of saying slope. So what I'm going to do is I'm going to think about these as like an x1 and an x2. I'm going to go to negative 3 and I'm going to put a dot on the graph, okay? I'm going to go to 6, and I'm going to put a dot on the graph. And I'm going to think about the slope of this line. This line has 0 rise. It has run. It runs 9. But anyways, the slope is 0 over 9, which is 0. So the average rate of change is 0. Does it change as it moves from left to right? Yes, it does. But on average, it gets right back to where it started. So the average rate of change is nothing. There you go. That is all the bonuses for your basics quiz and all of the basics quiz. That shall be Friday. Good luck to you.